Okay, so basic electrical engineering. So this is one of the important subject your daily life is based on basic electrical engineering only. Okay, so your home appliances like fan, TV, refrigerator, motors, all are operating on electric power supply only. Based on power supply only, these all equipments are working. Am I right or not? So that's why you must know importance of electrical equipments and electric power. So electric power is must and should. So then only it is possible to operate another systems. Okay, this is the basic need. No? So basic need is water, power. So that is the importance of power. Without power, we can't do anything. Without electricity, can't do anything. So that's why everyone is concentrating on electricity. So not only CSE, not only triple E, you are from CSE. So this is one of the subject introduced for you because of it's a basic need of importance of basics. Okay, it's clear. So from this, first I have to introduce some concepts about electrical circuits. Okay, first to all of you, right? When I'm explaining the concept, everyone write in your notes. I will give the sufficient time to write. It's clear. First, what is my electrical circuit? All of you write this concept in your notes. Okay, electrical network. What is meant by electrical network? First, a combination of various electrical elements, resistor, inductor, capacitor, or voltage source or current source. Okay, connected in any manner whatsoever is called electrical network. Okay, your home applications is one of the network. Okay, so fans, TVs, refrigerators, lights, they all are connected in your home. That complete network is called electrical network. Okay, connected in any manner whatsoever in electrical is called electrical network. We may classify electrical circuits elements into two categories. So one is passive elements and the second one is active elements. First one is passive elements and the second one is active elements. So this is one of the basic concept is required to understand the basic electrical engineering. Okay. So generally the active element is nothing but a power generating system. Power generating system is called active element. So generally the power is generated by using different type of generating stations. Am I right? By using thermal power plant, by using hydro power plant, by using nuclear power plant, diesel, gas, tidal, wind, whatever it may be. So by using this type of generating system, so we have to generate electricity, and then that electricity we have to transfer by using transmission line to the load. Am I right? It's clear. So that's why first we have to know the concept of what is meant by passive element, what is meant by active element. Okay. So right here, what is meant by passive element? Okay. The element which receives energy or absorbs energy and then either converts into heat or stored in an electric charge C or magnetic field L called passive element. It's clear. That means RLC circuits, RLC elements are called as a passive elements. The element which receives the energy or absorbs the energy and then either converts into heat or stored in an electrical energy. See, electrostatic field, capacitor. Capacitor store the energy in the form of electrostatic field, C. Capacitor C is denoted by C. Store the energy in the form of electrostatic field. And inductor, that is called coil, store the energy in the form of magnetic field. Okay. Generally, these R, L, C is called as a passive elements. Okay. And next, active element. The element that supply energy to the circuit is called active element. It's clear. The element that supply the energy into the circuit is called active element. It's clear. All of you right? This is the concept active element. What is my active element? Examples of active elements are include voltage source or current source generators, okay, and electronic devices that require power supplies. Okay, so these are called active elements. Generally, generator is one of the active element, and voltage source and current source. These are all two are called active elements. Okay, in a network, an electrical network, two sources are there. One is voltage source and current source. Okay, the two sources can be considered as active elements, and generator is also called active element. Some electronic devices are generate the electric power, that is also called as active element. Okay, a transistor is an active element, active circuit element. Transistor, you know well, you already studied in the intermediate level. A transistor is an active circuit element, meaning that it can amplify the power of a signal. Amplify the power of a signal. Okay, that means the power can be increased by using transistor. Power amplifiers. By using power amplifier, it is possible to generate, is increasing the power level. It's clear. So that's why this transistor is called as an active element. In other hand, transformer is not an active element. Transformer, you already, you know some little bit concept about transformer. So you are generally also you are seen transformers. The transformer is not a active element. Transformer is not an active element because of it's not amplify the power. Try to consider. This is very, very important. Transformer is not an active element. Just step up the voltage levels. Okay. Step down the voltage levels. Just voltage levels are changing, not power levels. Power levels remains constant. It's clear. Power levels are remains constant. That means input to the transformer, output to the transformer, the power is constant, but voltage levels are different. Okay. That means V1 I1 input side, V1 I1, voltage V1 input side, current I1 input side, V1 I1. That is power is nothing but V1 I1. That input side voltage, input side power, and output side power is constant always. That's why the transformer is not an active element. Okay, because it does not amplify the power level, and power remains same both in primary and secondary sides. Transformer, in example, passive element. It's clear. All of you completed, I think. This electrical network and passive element and active element. And then coming to the bilateral element, this is one of the important concepts also. Bilateral element. Conduction of current in both directions in an element, example, resistance, inductance, capacitance, with the same magnitude is termed as bilateral element. It's clear. So the bilateral element means even though if you are changing the terminals from one side to another side, for example, this can 1 and 2. Okay, if you are interchanging the terminals, so here like this, I mean interchanging the terminals from one terminal to another one, 1 to 2 or 2 to 1. Okay, plus minus or minus plus. If you are interchanging the terminal, okay, the conduction of current in both directions in an element, okay, with the same magnitude is termed as bilateral element. Even though the positions of the resistor is changing, same value of resistance, R1 here also, R2, both are same. Okay, if you are changing the position of the resistor, I mean, if you are changing the position, that is polarity of the connections of the resistor into the circuit. Okay, plus minus and minus plus. Even though if you are changing the connections, if you are changing the terminals between the 2 points, between the supply, the current magnitude is constant. It allows the current in both directions now. Okay, bilateral element means it allows the current in both directions. It is allow the current in this direction and it is allow the current in the direction. Two directions, it allow the current. It's clear. Two directions. Positive to negative, negative to positive, it's allow the same magnitude of current. That is called bilateral element. Okay, it's clear. And next, unilateral element. Unilateral element. Conduction of current in one direction in termed as unilateral. Example, diode and transistor elements. It's clear? Conduction of current in one direction is termed as unilateral element. That means only one direction. It allows the current in one direction, but not resistor. Resistor allows the current in both directions. That's why it's called bilateral element. But unilateral element, the current is allows only one direction. Okay, if these terminals are changing, plus to minus and minus to plus. If you are changing the terminals A to B or B to A or plus to minus or minus to plus, the diode cannot allow the current. During forward bias only, the diode can allow the current from. So like this, no? If it is a diode is forward biased, positive is connected to the diode positive, then it is forward biased and it's allow the current. If you are changing the position of the diode minus to plus like this, the diode is positive and negative. That is called reverse biased. That means here positive is connected to diode positive, that is forward bias, means it acting as a short circuit. It allows the current in one direction. But if you are open the circuit, if you are connecting in the reverse manner, minus to plus, okay, that means it acting as an open circuit. It does not allow the current, means it acting as open circuit. Under open circuit condition, under open circuit condition, no current flowing to the circuit. Diode acting as open circuit. Okay, so that's why the diode is called as a unilateral element. Diode, transistor, BJT, MOSFET, IGBT, the different type of electronic devices are only some unilateral devices. Conduction of current in one direction, but in not here, conduction of direct current in both directions same. R1 is equal to R2. So and the resistance offered by the circuit is also here same. If you are connecting the plus minus and minus bias, the resistance is same. Here R1 and R2 are same. Is clear? During positive direction, plus to minus and minus to plus, the resistance of the circuit is cannot be changed. But here, resistance of the circuit is changing if you are changing the positions of the terminals of the diode. Okay, if the positions of the this changing, I mean, plus minus is forward bias, means the low resistance. It offers low resistance. It acting as a short circuit. That means the resistance offered by the diode is very, very less. Okay, in the range of milliohms or okay micro ohms. It's clear. During forward bias condition, the diode acting as a short circuit, so its resistance is very, very less. But during reverse bias condition, it acting as a open circuit. Under open circuit condition, ideally infinity current, infinity resistance. Under open circuit condition, resistance is infinity. That's why it acting as open circuit. No current flowing through the circuit. That's why the resistance is very, very high in the range of mega ohms. It's clear. Understood? That's why R1 is not equal to R2. But during positive, this R1 and R2, I mean across the resistor, R1 R2 both are same, but diode and transistor and different type of devices. So the resistance is different. That's why during forward biased, R1 is very less in the range of milliohms only or micro ohms. Reverse biased, mega ohms. It acting as opposite. Not allow the current. Okay, this is the concept of unilateral bilateral. Okay. Meaning of response, an application of input signal to the system will produce an output signal. The behavior of the output signal, which is known as response of the system. Okay, so nothing is there, simple concept. Okay, if you are giving the input signal to this system, then we will get output. That is the response. First, linear circuit. So how can say this is the linear circuit and this is the non-linear circuit? How we can say? By using two properties. First one is homogeneity property. Okay, two properties are there. First one is homogeneity property and the second one is additive property. All of you write this concept, new knows. Okay, so linear circuit. Roughly speaking, a linear circuit is one whose parameters do not change with voltage or current. Understood? Here linear circuit, okay, the parameters are not changing. That means R1 and R2 are same even though if you are changing the resistance positions. But this is a non-linear circuit. This is non-linear element. The parameters are changing. R1 is not same. Okay, resistance of the circuit is not same. Okay, a linear circuit is one whose parameters do not change with voltage or current. Okay, that is called linear circuit. Okay, non-linear circuit. Roughly speaking, non-linear system is that whose parameters change with the voltage or current. Understood? The diode is called non-linear element. The resistor is called linear element. Resistor, inductor, capacitor is called as linear elements. But diode, transistor, BJT, the devices are called non-linear elements. It's clear. So based on that homogeneity property and additivity property, we can say that there is a linear system or non-linear system. Okay, it's completed. So complete fast. So nothing is there. Some simple concept. Linear circuit is one whose parameters do not change with voltage or current. Complete fast. Who is that? That's why I'm going to log the sessions. So joining and entering into the class and leaving to the class, you are making noise. It's clear. Then we have characteristics of voltage versus current of linear circuits like this. Even though your positions of the resistors are changing, one terminal to one positions, polarity of the resistors are changing, this voltage and current relations is not changing. It's clear. But if you are changing like this, for example, diode, okay, if you are changing the diode positions, the resistance of the circuit is changing. So voltage and current relations like this. V is equal to I square like this. V is proportional to I square. So parabola, y is equal to mx square like this. So non-linear characteristics. No? This is called a non-linear characteristics. These are the characteristics of linear circuit and these are the characteristics of non-linear circuit. It's clear? And then coming to the units of the system, SI units. Completed, I think. And then coming to the SI system, units of SI system. Generally, so in each system is having some units. So meter, we are indicated like this: m, kilogram, kg, seconds, s, ampere, a. Also Kelvin, mole, and candela. So these are the different type of base units. Okay, by using this base units, some derived units are there. Work or energy, joule. You can call that as a joule. Power, rate of doing work, watts. Our electrical point of view, power, rate of doing the work is called watts. 1 watts is equal to 1 joules per second. All of you write fast. Okay, these are the derived units from the base units. Okay, work or energy is called joule, and power or rating of the watt. Power units are watt. Some basic, some introduction, some concepts are measurements. Any measurements can be expressed in terms of unit or unit with prefix modifier. 10 to the power of minus is 9 is called nano. No? The symbol is nano. So why? Because nanofarads, capacitor, nanofarads, microfarads. So we have to indicate like this. Okay, that's why we have to know must what is meant by 10 to the power of minus 9 nano, 10 to the power of minus 6 micro. So in symbol 10 to the power of minus 3 milli, 10 to the power of 3 kilo, and 10 to the power of 6 mega yam. These are the symbols. So we have to indicate in electrical circuits. Okay, nanofarads. Okay, microfarads, milli ohms, kilo ohms. Okay, mega ohms. So like that. So example 12.3 milliwatts. So we have to indicate like this. Okay, 0.0123 watts and 1.23 into 10 to the power minus 2 watts. Okay, and 12.3 into milliwatts, 12.3 milliwatts. So like that. So these are the some factors required to understand the some concepts of electrical networks. It's clear? All of you completed. Charge. Charge is conserved. Okay, it is neither created nor destroyed. You know well. Symbol representation of the symbol like this: Q or small q, capital Q or small q. Units are coulomb. Okay. The smallest charge, the electronic charge, is carried by an electron minus 1.602 into 10 to the power minus 19 coulombs. You know well, these are all concepts, but just I recall this concept before going to the actual class. Okay. A proton, a positive polarity, the 1.602 into. In most circuit, charges in motion are electrons. Okay. Nothing is a simple concept. Current and charge. What is the relation between current and charge? Current is the rate of change of flow, rate of charge flow. You know well, current is the rate of charge flow. Okay, 1 ampere is equal to 1 coulomb per second. You know well, 1 ampere is equal to 1 coulomb per second. These are the standards, some concept of current and charge. Okay, the charge and current is depending upon a conductor, cross section of the conductor. This is called conductor. It's clear. So these are the different type of charges. Direction of charge motion is called current. Current is nothing but charge. That is called electrons, flow of free electrons, flow of free charge. It's called current. Okay. So it's depending on the cross section of the conductor. You know well the relation R is equal to rho L by A. Am I right? Okay. So it's completed. I think complete first and then. Don't use pencils, scales. Okay. Just draw the rough diagrams. It's clear. Next, current or charge. So the current is designated by capital I or small I. So we have to indicate like this, capital I or small I. Okay. Is the rate of flow of charge. Okay. Current must be designated with both directions and magnitude. Current is compulsory, some having magnitude, is having some magnitude. That is called 3 amps. Here are indicated like this. So minus 3 amps means, so minus means instead of supplying the power, it's taking the power from the other source. Currents are same based on direction of current. So we have to indicate like this, polarities. Okay. So the current direction flowing into the circuit. So like this manner. So we are assuming this direction from here to here. That's why 3 amps. Here also current direction same, but we have to indicate minus 3 amps. Here also this is the same polar, same way we have to indicate. Okay. 3 amps is current is in this way means in this direction minus 3 amps. Because of that direction is changed. Okay. We have to indicate some magnitude also. Minus 3 amps and 3 amps. Okay. In every circuit, so we have to indicate. So we have first we have to concentrating on one direction. So that is our direction, our direction. If the current direction is reverse means that is negative. Okay. For example, current I'm assuming current A to B is positive. I'm assuming I don't know what is the current direction in the circuits. Okay. So A to B, let us assume A to B current direction is positive. I'm assuming like this. I'm assuming A to B the current direction positive means plus 3 amps like this. But our actual direction is, I'm assuming as direction is A to B, but current is flowing from B to A. So in that case, we have to consider current magnitude is minus 3 amps. Okay. So this is the charge and current graphs. That means here charge may be negative or positive. Current may be negative or positive. So this is the concept from the graphs we have to understand. The relation between current and charge is nothing but I is equal to dq by dt. Okay, q by t, I is equal to q by t. I is proportional to I is equal to q by t. That means change of charge with respect to time is called current. So, okay, all of you draw this draw rough diagram. Don't use pencils and scales and sketches. Okay. So, voltage. Current is completed, the charge is completed, then voltage. Here, try to consider here. Voltage. So this is nothing but one system, one network, one load, just like a load. That may be your house. This may be your house. Another house. Okay. Is a connecting loads. Number of loads are connected in parallel in the system. Okay. Here also the one of the system is connected like this. Okay. When 1 joule of work is required to move 1 coulomb of charge from A to B, there is a voltage of 1 volts between A and B. Okay. Voltage V, so indicate in capital V or small v across an element require both a magnitude and polarity. With the magnitude and polarity, we have to indicate. So try to consider with these two figures, A and B. Try to consider these two figures. Here A to B, what is the polarity at A plus and polarity at B minus? No? Okay, so we have to indicate this is the assumption V is equal to minus 5 volts. Okay. So here, when you are coming to the circuit B, here polarities are changing. Okay. That means here instead of minus, we have to take plus. That means two circuits are representation is same. These two circuits are both are same. A2 is equal to B. It's clear. These two circuits are both are same. So even though if you are changing the polarities like this, that means if you are changing the polarities here to here, this polarity of the voltage source is changing like this, minus 5 volts to plus 5 volts. Because of these polarities are changing. Here plus, na? Here but here minus. Here B minus, na? Here plus. Okay, I'm changing the polarity. That's why these polarities also, here also voltage source polarities also change. Okay. Similar way, here also V is equal to 5 volts. In this figure C, plus minus, I'm assuming P is equal to 5 volts like this. If I am changing the polarities like this, plus 2 here and minus changing. So what is the polarity of the batteries like this? V is equal to minus 5 volts. So we have to indicate this. These two circuits are same. These two circuits are same. A and B and C and D both are same. These two circuits and these two circuits. It's clear. Even the polarities are changing. Okay. Try to consider here. Some of the examples are so maybe given like this. Polarities are plus minus and minus plus with 5 volts and plus minus with minus 5 volts. It's clear. So in this way, they are giving polarities are like this. Understand? And next power. Power is equal to V into I. You know well. So there are different type of relations. You know well. The power required to push a current I coulombs per second into a voltage V joules per second is known as power. VI. Okay. Joules per second is watts. Power required to push the current I called coulomb per second into a voltage V joules per second. Power is equal to relation. This is one of the relation. So not only this relation, power is equal to in the form of resistance, in the form of load. Resistance is called load. Okay. Power is equal to I square R. Power is equal to V square by R. There are different type of relations are there. Okay. When power is positive, the element is absorbing energy. Okay. Power is positive, the element is absorbing energy. Try to consider it. This is a very important part. When power is positive, the element is absorbing energy. That means it load. It acting as a load. It's clear. It acting as a load means just like your home appliances, fans, TVs, is are consuming the power. No? That means across your devices, across your loads, that may be TV, fan, motor, across that loads, the power is positive. That means absorbing the power, absorbing the energy. It's clear. When power is negative, the element is supplying the energy. It's clear. When power is negative, it means delivering the energy. Supply the energy to the load. It acting as a source. It's clear. Generating system is called as a source. Understood? Generating system is called as a source and load domestic system. Okay, industrial systems, industrial loads, they are all consuming the power. We are all are taking the power from the source. That's why the power is positive across the loads and the generating system power is negative. Okay, these are the standard notations we have to consider. It's clear. Examples of power here. So one of the load, one of the house is a house A, house B, house B like this, house C. So we have to consider like this. Okay, here 2 volts we are applying. I'm applying here 2 volts and the current is 3 amps. What is the power in the circuit? Power consumed by this home? 6 watts. Am I right? Understood. It acting as a load now. It acting as a load. That's why the power is positive plus 6 watts. So V into I, 2 into 3, 6 watts. How much of power is absorbed by the elements below? Nothing but power is equal to 6 watts. 2, 3 is 6. Positive. Okay. The current direction will be like this. That's why we have to indicate positive. If it is opposite direction, minus. It's clear. And then here, minus polarity, here positive polarity, minus 2 volts, minus 3 volts. Understood? That means minus 2 into minus 3 plus 6. It also absorbing the power. It is acting as a load. A is acting as a load and B is acting as a load. Two loads are acting as a loads only. Absorbing the power. Okay. When power is positive, the element is absorbing the energy. These two, A and B, are absorbing the energy. Power is positive. And then coming to the C, so what is the voltage here? 4 volts. And what is the current here? Minus 5 amps. So what is the power here? Minus 40. Minus 20. Minus 20. So that means actually the supplying the power to the load. Okay. It acting as a source. No? Minus 20 watts means it acting as a source. Instead of consuming the energy, it is delivering the energy to the another system. It acting as a source. Actually supplying the power is called source. It's clear. Circuit elements. A circuit element is usually as 2 terminals. Sometimes there are more, 3 or more. Some elements, resistor only 2 terminals, inductor only 2 terminals. Okay. But BJT, you are BJT. Okay. BJT transistor, some transistor concept, 3 terminals are there. Okay. Anode, cathode, one gate terminals also there. MOSFET, gate, source, drain, like that. 3 terminals are there. But the circuit elements usually as 2 terminals. So sometimes there are more. Okay. The relationship between the voltage across the terminals and the current through the device defines the circuit element model. Okay. So based on that relation between voltage and current, we have to explain the concept of circuits. It's completed. The relationship between the voltage V across the terminals and current I through the device defines the circuit element model. So V and I. A power is passed. Consuming the power is absorbing the energy. So next, voltage sources. Completed, I think. Voltage sources. So we have to indicate voltage sources like this manner. An ideal voltage source is a circuit element that will maintain the specified voltage Vs across its terminals. An ideal voltage source is a circuit element that will maintain the specified voltage Vs across its terminals. Okay, the current will be determined by another circuit element. So that means based on loads, if you are increasing the, for example, in your home, if you are turn on the loads, that means you have turned on the fan. Okay, all fans are turned on or all lights are turned on. That means the load current is changing. The load current is increasing. Based on load currents, the current is changing. Based on loads only, the current magnitude is different, but voltage is constant. Here voltage constant, but based on loads only, the current is changing. Am I right or not? If you are turn on the more loads, it draw the current from the source is very high. So you are observing that in your home appliances, the supply voltage is 230 volts only, single phase 230 volts. For a single phase system, 230 volts. For 3-phase system, 440 volts. That is constant. That is fixed. The voltage is constant. Okay, but current is changing according to the load. If you are connecting more number of loads, means it draws the current from the supply is increasing. Okay, but supply voltage is same. Okay, the current will be determined by the another circuit elements. Means that if you are in home appliances, the number of loads are connected in parallel. If you are increasing the current, draws the current from the supply is increases. That's why the current drawn from the supply is increasing. Okay. So this current direction is not fixed. So that means your voltage plus minus means it's not delivering the current. It's not absorbing the current. Based on other circuit parameters, other sources, the current direction will be changing. Okay. If 2 or more sources are connected into a circuit network, if 2 or more network 2 sources, this one source and the same like this, another source is also connected into the network. That means which one is higher in magnitude voltage, that can able to supply the power to the load. Okay, that's why at that condition, the current is coming to the source. Another source is supplying the power. Compared to this, Vs, for example, Vs is equal to 20 volts. Another source like this, another source Vs is equal to 100 volts, for example. That means 100 volts magnitude is very high. That's why it can supply the power to the another systems. So that's why the current is entering like this. Okay. So there is the voltage sources. And then current source. So these are ideal voltage source and ideal current source. Then current sources. An ideal current source is a circuit element that maintains the specified current flow IS through its terminals. The voltage is determined by the other circuit elements. Understood? Ideal current source is a circuit element that maintains the specified current flow IS. That means current here constant. For example, 2 amps. That current is constant, fixed. For example, current IS is 5 amps, fixed. It can supply up to 5 amps only. Okay, but the voltage drop is depending on another circuit parameters. For example, if we are resistor connected here, one of the resistor is connected here, means based on this resistor, the current, the voltage drop here different and voltage is different. Voltage is determined by the another circuit elements. Okay, based on elements, I mean loads, the voltage is changed. Okay, so battery has a voltage source. It's completed, I think. That battery has a voltage source. A voltage source is an idealization, no limit on current. Okay, and generalization, voltage can be time varying. For ideally, the low limit on current. No? Ideally, we can consider as a no limit on current. Voltage source is an idealization, no limit on current. But practically, but generalization, voltage can be a time varying of battery. Okay, the life of the battery is increasing, means the charge goes on decreasing. No? Okay, just like our mobile batteries. Okay, a battery supply constant DC voltage V, but practice a battery has maximum power. Okay, so these are the battery representation of symbol. Okay, here plus minus means DC. Okay, so we have to represent like this, plus minus polarities are like this. So the symbol is for AC. This is the symbol for AC. But here plus minus means highest magnitude here. That means here phase and here neutral. Here phase is connected and here neutral is connected like this. Batteries, this is called DC battery. Here these two are, this is called voltage source. This is called battery. Okay, representation polarities. This is called AC source. So like this. Plus minus means here higher in magnitude, here lesser in magnitude. High potential, low potential, like this. Here phase, neutral, like this. Next, dependent sources. Dependent sources. So there are different types of dependent sources. Okay, so A, B, C, D. 4 types of sources are there. 4 different types of sources we have to use. 4 different types of sources. Dependent current source A. Okay, so try to consider here. So this is the indication is nothing but current source. Okay, the arrow is nothing but current source. Try to consider it. This 4 circuit, 4. Here arrow indication is called current source. Here arrow indication is called current source. Here plus minus indication is called voltage source. Here plus minus indication is called voltage source. Try to consider it. Simple concept. Nothing is there here. Try to consider here current direction. Okay. Arrow is means current source. Here arrow is means current source. Here plus minus means voltage source. Here plus minus means voltage source. Try to consider here. This is current source. No? This is depending on K into Ix. That means current dependent current source. KIX means current dependent current source. This depending on current source is depending on KIX. Understood? Understood? Here coming to the B. Current voltage dependent current source. This is current source. This is current source. Okay, current dependent current source. Here voltage dependent current source. Current source is fixed. Here current source and here current source. Okay, voltage dependent current source. Here voltage is depending on voltage. Okay, this current magnitude is depending on voltage. That's why this is called voltage dependent current source. And next here, this is called plus minus means voltage source. No? Plus minus means voltage source. Here also plus minus means voltage source. Here KVX is called voltage. That means voltage dependent voltage source. It's clear. This is called, C is called voltage dependent voltage source. Here next D is called This is voltage source. This is a voltage source, but it's depending on current. R into Ix is called current. Okay. I mean, current dependent voltage source. It's clear. Current dependent voltage source. Is it clear, all of you? So Ohm's law. So you know well, Ohm's law is a linear. V is proportional to I actually. The proportional constant is called resistance. V is equal to I into R. The equation is called Ohm's law. So the current entering into the circuit, current entering into the resistance. Okay, I'm considered as a plus here, and here minus. The voltage here. So V is equal to I into R, I into R. So current entering into the load is nothing but plus and leaving minus. So standard notation, I'm considered like this. Current entering into the resistor, I'm considered as plus and leaving minus. So these are the different type of resistors, typical resistors, power resistors, and 10 ohm resistor and circuit symbol. So we have to indicate like this. So, okay. And the IV graph, voltage and current graph of the resistor. So like this. You know well, V is proportional to I now. Okay. V is proportional to I. That means the linear. So we have to get the relation between current versus and volts. So linear manner. So I is equal to R is equal to V by I. You know well. So this called voltage 8 volts at this point. 8 by 4, 2 ohm resistor. Okay, this graph is for a 2 ohm resistor. Okay, nothing is a simple concept. In this example, the slope is 4 by 8. Okay, y by x na. So that's 4 by 8 or 0.5 ohm inverse. The resistance is slope is always constant. If it is linear, the resistance is constant always. Here, anywhere, the resistance is constant. Okay, on the wave, on the graph. Okay, power absorption. Resistors absorb the power. V is equal to I into R. Power is equal to V into I. V square into R. I square into R. V square by R. I square into R. It's clear. Resistor is always absorb the energy. Absorbing the power. Power is equal to V into I. V square by R. Or I square into R. It's clear. Positive power means device is an absorbing energy. I've already explained this concept. Power is equal to positive means it absorbing the energy. Power is always positive for resistor. Okay, power is equal to V into I. It's clear?